Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Today's my topic is Charle's law. This is the second law. One is Boyle's law, then Charle's law. It is between volume and temperature. Volume is directly proportional to temperature, keeping pressure constant. In Boyle's law, volume and pressure are inversely proportional and keeping temperature constant. But in this law, volume and temperature are directly proportional and pressure keeping constant. A law stating that the volume of an ideal gas at constant pressure is directly proportional to absolute temperature. This is Charle's law. List variables. If volume are 2, V1 and V2 and T1, T2. Plug variables into Charle's law equation and solve for V2. If V2 is unknown, then volume V1 4.9 ml, V1 upon T1. So T1 is 313 Kelvin. Kelvin is the unit for temperature, and this is centigrade plus 273 equals to Kelvin. If T2 is 373 Kelvin, it is after addition 273. So 373 and V2 is unknown, so V2 can be found by V2 in one side and 4.9 upon 313 multiplied by 373 Kelvin is the answer. When we simplify, then we will get answer. Charle's law at constant temperature, constant pressure, the volume of a gas varies directly with its Kelvin temperature. Kelvin is the unit for temperature. Kelvin is the unit for temperature. V1 over T1 equals to V2 over T2, or V2 over V1 equals to T2 over T1, or V1 T2 equals to V2 T1. Because when we cross multiply, then we will get V1 T2 equals to V2 T1. If T2 is unknown, then the equation becomes V2 T1 upon V1. These are the explanation of Charle's law. If volume is less and temperature is T1. By increasing temperature, the flame size is increased, so volume also increase. The gas molecule takes more space between the particles. And temperature, red is the temperature, so T1 and T2 is more increased. This is the graph. Volume and temperature are directly proportional, so direct proportion graph always is straight line. This is the diagram. Mass is fixed and pressure and temperature. Temperature is 375 so volume also increase. And the graph volume and temperature is direct proportion, so it is in a straight line. Again, the revision, the law states that the volume of an ideal gas at constant pressure is directly proportional to absolute temperature.